So if you recognize this shirt, it's because I wore it for my recent Spinosaurus related animal video. And now I have to wear it again, and this time specifically because of Spinosaurus. And Spinosaurus is kind of a pain. This is largely because the first specimen of it, this one, where I say show me the holotype, got blown up during World War II, so we don't have that anymore. Since then, there have been bits and pieces found throughout many decades. However, that all really culminated in 2014 with the discovery of a more complete specimen, even more complete than the holotype was. And that's really exciting. Hey, look, we can finally do some research on it. For example, we can look at it and go, hey, it had really, really dense bones, which those authors used to suggest that it was actually swimming underwater after prey, because the dense bones would help it sink. Since that 2014 paper, though, there's been a lot of back and forth in academic circles of, no, it actually probably didn't swim underwater. It was probably hunting more like a heron, wading on the side of streams and striking out at prey. And then again, people going back and going, no, look, it has this large tail and it's paddle-like. It probably used that to help propel itself through the water. And then other people going, yeah, but it's missing all of these other aquatic adaptations we would expect. It's a lot of back and forth. And this paper is on the side of, no, it didn't swim underwater. And that's because it looked at the density of those bones in a much broader scale kind of metric. And there was actually a paper like this a few years ago that suggested, hey, no, look, it is really dense. It definitely swam underwater. The problem is they looked at rib bones and some of the limb bones, but not many of the other bones. And that's part of what this paper did, is it looked at the whole skeleton, was able to say there's actually a lot of pneumaticity along the vertebra. Pneumaticity essentially just means that the vertebra help to support air sacs, which if you're a diving organism, having extensive air sacs really isn't that likely. And in fact, these air sacs are even more expansive than what we find in things like baryonyx. Baryonyx being another spinosaurian that was normally suggested to be much more living on land and not necessarily as attached to the water as something like Spinosaurus might have been. By using these air sacs and applying the densities of the other limb bones to certain 3D models, they were able to say, yeah, probably couldn't swim underwater at all. Those air sacs would have given it too much buoyancy and it would have been forced to essentially swim at the surface. It would have been too buoyant to actually go down. And this makes a lot of sense when you look at the measurements from the 2022 paper that did more math on the density of those bones. And that's because they essentially just left out certain parts of it. And that's because throughout the bones of Spinosaurus, there's a lot of variability in how much actual density you do get, with some parts being less dense and some parts being more dense. So if you sample parts that happen to be more dense, you're going to get a higher number than you would expect. Additionally, again, they didn't really look at the vertebra, mainly the ribs and the limb bones. And then there's the dataset that was used in 2022, which fundamentally ignored some of the actual issues with how certain tetrapods move through the water. And that includes things like some of the organisms being removed because they're too aquatic. They're things like whales, but then also including other organisms that were pretty similarly aquatic to whales. So it really is this kind of inconsistent usage of their data that led to that result that, yeah, Spinosaurus definitely swam. Additionally, mammals, like whales, totally different from reptiles, especially dinosaurs, because dinosaurs are so much closer related to birds. And they basically threw out all the birds because most diving birds fly. The thing is, though, they're not quite birds and they're not quite normal reptiles either. So when you're looking at Spinosaurus, it's kind of in this middle ground where, sure, some traits like the dense limb bones do seem similar to crocodilians, for example. However, again, extensive air sacs, not something we see in crocodilians, but we do still see in diving birds. In diving birds, though, that air sac system is much reduced, and again, it's expanded in Spinosaurus when compared to even things like baryonyx, another large theropod dinosaur. So why would it have expanded this air sac system if it was diving? It seems much more likely that the opposite would have been the case. So essentially, this paper is just pointing out a lot of statistical method and other data misuses that the 2022 paper had. And I think this figure best shows it, where they have a graph plotting out all of their data for one of their measurements from the 2022 paper. And then on the right is the same kind of box outside shape and random points that fit inside of it. And the correlation for each of these shapes being legitimate is basically equal in both of them. So the data that they used in the first Spinosaurus paper in 2022 is basically no different statistically as far as relevance as random data points. So it's not really super useful for showing that, hey, yeah, Spinosaurus totally dove. And that's unfortunate. It would be really nice to have better information about Spinosaurus. And then, of course, there's the main issue that I think is most important, which is all of these papers that have come out recently and said Spinosaurus definitely swam or hunted underwater are basically ignoring the entirety of the Hohn and Holtz 2021 paper, which I have an entirely separate video about. And this is a nice summary video of it. It was actually even tweeted out by one of the authors saying, hey, this is a great video explaining our paper. But essentially it just points out that there's a ton of different traits that Spinosaurus have, all of which suggest it wasn't swimming under the water. Now, it still probably swam better than most dinosaurs. That paddle-like tail and some of the denser limb bones probably helped it with that. But it wasn't diving. And there's a big difference between being able to swim, most animals can swim, and hunting in the water. Those are two entirely different traits. So again, it's just more evidence that Spinosaurus really wasn't swimming through the water like a fish after prey. Instead, it's much more likely that it was waiting at the edge of this massive river that it would have lived alongside in North Africa and striking at different large fish or even crocodilians. It would have been at that size fairly generalist as long as it could actually fit it in its mouth. Hey everyone, thanks for watching. Yeah, so for Spinosaurus, I think it really all comes back to Hone and Holt's 2021. Until someone has a good paper that addresses the many concerns that they bring up, I don't really think Spinosaurus is going to be that likely to change from being a wading animal. And that's still really unique. So if it's your favorite dinosaur, just because it's not swimming through the water doesn't mean it's not really interesting and unique. It's just the dialogue around it can get a little frustrating at times. With all that said, be safe, take care, and don't go extinct.